So we have our second practice problem with limiting reactants. We have ammonia plus oxygen produces nitrogen monoxide and water. First of all, the first thing you need to do is make sure it's balanced. The equation is balanced. I've balanced it for you. Our second step is to take the given amount of reactants and convert them into the amount of product that we want. Now, this has two products. This is our first question with two products. So you have to identify which product is the important product, which one you care about. So all you do is find that in the problem. It says how much water can be produced. So how much water can be produced. So we want to look at H2O. We don't care about nitrogen monoxide this time around. So we need to convert our given moles of reactant into moles of product. And I want you to try to solve this first on your own, and then you watch the video to see if you went through the process right. So you got 16 moles of NH3, and we want to convert that into moles of water. So we're going moles to moles again. So 16 moles NH3. Now remember, my second step right here within my picket fence is to have the mole ratio that I get directly from the equation. So I got moles of NH3. That's how much I've been given. Now I look to my equation and I see I have 4 moles NH3. 4 moles NH3 right there. And how many moles of water is that equivalent to? Well, I get that from the equation as well. So I look here, I have 6 moles H2O. And I look at H2O because it's how much water can be produced. That's what it asked me in the problem. And this is my mole ratio that I get directly from my equation. So then I just multiply straight across and solve. I have 16 multiplied by 6 equals 96 divided by 4 equals 24. So in the end, 16 moles of NH3 will produce 24 moles of H2O. And I just multiplied straight across and divided. I needed to cancel out moles of NH3, cancel out moles of NH3. That's how I ended up with moles of H2O. Now remember, with step 2 of this process, it's always 2 steps of dimensional analysis. So next I have my given, which I get from the problem, 19 moles O2, and I need to convert that into moles of water. So I do it the exact same way. Set up my dimensional analysis problem. It's always going to be a 1-step problem. So I get this, 5 moles of O2, 5 moles O2, keep doing that, 5 moles O2, get that directly from my equation, and this is my mole ratio, so I got to see how many moles of H2O I have in my equation. In this case it is 6, same as the last problem up here, 6 moles H2O. Again, I'll just multiply straight across and divide, so I have 19 multiplied by 6, which is 114, divided by 5, I get 22.8 moles of H2O. So I crossed out moles of O2, solve for moles of H2O. Remember this right here, my second step right here, I am getting these numbers directly from this equation right there. And this step, I'm getting these numbers from the problem itself because these are my givens. Just as a reminder. Okay, now I look at my two numbers. I have 24 moles of H2O was produced by my NH3, and 22.8 moles of H2O was produced by my oxygen. So how much product is actually produced? If you remember your steps, we take whichever one is less, in this case 22.8, and that is the one that was actually produced. So 22.8 moles of water is actually produced. And then what is my limiting reactant? I go with whichever reactant produced less, so 22.8 was produced by the oxygen, so O2 is my limiting reactant.